My name is Ishwar Sai. My experiment is fluid mechanics in competitive road bikes. Applying fluid mechanics principles, engineers and cyclists have transformed road bikes into aerodynamic machines that cut through air going faster than with less effort.
City bike versus road bikes. One of the biggest differences between a conventional city bike and a competitive road bike lies in the frame design. City bikes are built for comfort and utility, often with round tube frames that create more drag as they move through the air. Drag is a force that air applies against any object moving through it, and in cycling is the number one factor to slowing us. Turbulent air. Down a city bike's round tubes create a large wake of turbulent air as they move. This turbulence creates a low pressure area behind the bike, increasing drag. So fluid mechanics teaches us that reducing these turbulent wakes is key to growing faster. Now look at the road bike's frame. The tubes are shaped like teardrops, a design inspired by fluid mechanics to reduce drag. The narrower tapered shape helps air flow more smoothly along the frame, reducing turbulence behind it and minimizing drag. This means less air resistance, allowing to maintain higher speeds with less efforts. Riding position matters the most. Let's talk about rider positioning in competitive racing. A cycle body accounts for 70 to 80% of the total track. So to maximize speed, riders use an aerodynamic low positioning to reduce the frontal area. The smaller the frontal area, the less air they have to push through. Here is a simplified illustration of how riding posture affects the riding speed. The first formula is used here, where Fd is a drag force, ρ is air density, and V is speed, and Cd is drag coefficient, and A is frontal area of the cycle facing the air. Here are the three common seen riding posture adopted by the cyclists. When cyclist rides in an upright position, the body is more exposed to the wing, leading to a large frontal area. This larger area increases strike force, making it harder to reach high speed. In addition, this position creates a large weight region, the blue region hazing behind the rider, which adds more turbulence and further increases strength in the job's position. The cyclist leans forward, reducing the frontal area by targeting the body. This smaller frontal area decreases the drag force. Also, brake the region is reduced, meaning less air turbulence behind the cyclist together. This changes significantly reduces strength and make it easier to achieve higher speeds. In the extreme case of sitting the tube, the cyclist achieves the smallest possible frontal area, greatly reducing drag force. The weight region behind the rider also becomes minimum, reducing air turbulence even further. This posture is effective at high speeds, although it sacrifices some control over the bike and task is banned by the International Cycle Union. This is just simple illustration of drag force. With the power of fluid mechanics, competitive cyclists can go faster.